Hello everyone. So in our previous lecture we discussed how we can work with Jupyter notebooks. We will see some of the features related to Jupyter notebook today as well. And then let us work on how we can create variables, how we can work on them. Now in Python, if we are working on variables, variables are actually reserved memory locations which can be referred or which can be accessed using their identifier name. Now, whenever we declare a variable, a memory block is assigned to them. This memory address is something which is related to all the variables when we assign values to them. Now, because we are working with an object-oriented language, Python provides every variable as in the form of an object for the specific class. Now, whenever we are working with objects, we can do multiple tasks on these. For example, we can allocate memory to an object. We can deallocate or dereference an object from the memory as well. So let us see how we can define a variable. For any variable which you want to create in memory, you can use simple assignment operator, which will help you to assign a value to it. Once assigned a value, a variable becomes an object of that specific type, which the value is, or according to which the value you had assigned. Now I can print the value of variable. For example, I had declared a equals to 12. Now a is a variable of type int, or it is an object of class int. Whenever I will print a, it will print the value which is assigned to this a variable. Now I can also print the type which this a variable is being associated to. So when I'll run this code, it will display 12. 12 is the value, and it will display class int, which means this variable a is an object of class int. So whenever an object is declared, it will be assigned a reference ID in memory. So how we can check what is the reference ID given to this? I have a built-in function in Python which is ID. If I'll write ID and within parenthesis, if I'll write A, it will display the memory allocation assigned or memory address assigned to this A variable. Now, this means this A has been assigned a memory. Now, we can also delete or dereference the memory which is assigned to a variable. For doing that, I can use an inbuilt property which is del, and when I'll write del A, when I'll execute the code, there will be no output. Now, when I'll print the value of A, it will give me an error which says name A is not defined. Why name A is not defined, though we already had created a variable? Because we deleted the reference or the ID which belongs to A, and once this is deleted, we cannot access the memory location. So del can be used to delete the reference, or it can be used to dereference an object from memory. Now we can also do multiple tasks when we are working with variables. For example, we can assign one common value to multiple variables using assignment operator and then passing the value at the end. When I'll run this code, it will execute without any problem. And when I'll write print a comma b comma c comma d, and I'll be using separator equals to, let's say, space. When I'll run this code, it will print 10, 10, 10, 10. Means all the variables are assigned the same value as 10. Similarly, I can assign different values to different variables by comma separating them. For example, I had written x, comma y, comma z. Now, by assigning different values, we will write equals to, let's say I want to assign 10 to x, 2.5 to y, and a string to z. Now, I'll print these values, and once I'll execute the code. It will display 10, 2.5, and if I'll write print type Z and I'll execute the code, it will say class str. Similarly, if I'll write ID X, I'll run the code, it will display the ID of X. If I'll write ID Y, it will display the memory address assigned to Y. They will be altogether different. If I'll write ID Z, I'll execute it. It will give an address to which this Z or this variable belongs. Similarly, I can delete multiple variables. For example, I can write del x comma y. When I'll run this and then again I'll print ID x, it will then give me an error message that name x is not defined. Similarly, if I'll write ID y, because I deleted both of them, so it will again give me an error. So this is how we can work with variables by assigning multiple values to them, by assigning a common value to them, and also by using del method through which we can delete a reference given to a variable. Now in Python we have different ways to give comments also. For example, let's say if I am working with Jupyter Notebook, I can do one thing to write a simple text in my code. For example, let's say I want to write comments in Python. I can go to cell, I will select cell type and I'll click on markdown. And this cell will appear without any line number. And when I'll write something, for example, comments in Python. When I'll run this, it will not be displayed or it will not give you any output, but this will display like this. Now again, a new line has appeared. So this is how I can create a markdown cell in Jupyter Notebook. Now let's say I want to make some comments. I'll be using hash. Hash is used to give single line comment in Python. Similarly, I can give multiple line comment in Python using triple quotes. This is a multi-line comment. So when I'll execute this, a multi-line comment will display like this in Jupyter Notebook, but when you will be running it in a Python file, a .py file, it will not be displayed, while a single line comment will not be displayed at all. So this is how we can define comments in Python. A comment can be in the starting of a line using hash. A comment can be at the end of an expression or a statement. For example, if I'll write 2 plus 3 and I'll write hash operator. When I'll execute this code, it will give me only 5. So I can use a single line comment like this. Now Python gives you various ways to work on strings or string literals. For example, if I'll write a equals to double quotes welcome. This is similar to if I'll write a equals to single quote welcome. Both are same. So when I'll execute it and I'll print the value of a and b, both will display welcome. Similarly, I can write c equals to triple quotes welcome. This is also used to create a string. I can also write c equals to single triple quotes welcome. Again, this will display, or when I'll write print c comma d, it will display welcome. So strings or string literals can be given in 4 different ways, either in double quotes or in single quotes or in triple double quotes or in triple single quotes. Similarly, if I want to use them or I want to print them, for example, let's say I want to print welcome or I want to print a line in which I want a text to be inside double quotes. For example, this is a text to be displayed. Now I want text to be in double quotes, or I want text to be in single quotes. Let's say if I want text to be displayed in single quotes, I'll be doing this. So this will display text in single quotes. So whenever I want to display a content in single quotes, I'll enclose the entire content in double quotes. If I want to display a content in double quotes, then I'll need to enclose the entire content in single quotes like this. When I'll do this and I'll execute the code, it will display that content in double quotes, the one which I had enclosed it in. So if I'm working with the text, if I want to print them using quotation marks in the text, I have to use an approach where if I'm using double quotes, the text which I needs to be inside the quotation marks must be opposite to the one which I had used for the entire content. So if it is single quotes, the text should be in double quotes. If it is double quotes, the text should be inside single quotes. Now I can have multiple quotation marks, as many as I want to display, like this. So this is how I can use text to be displayed inside a given printf statement. Now, when I'm working with Python, I can work on different type of operators. Now, what do you mean by operators? Operators are special symbols which have a task assigned and which helps us to perform a given operation uh, with respect to the type of operands we use along with them in an expression. So, suppose I want to work with operators in Python. Python comes with number of operators. Like Python has the very first category of operators, which are arithmetic operators. Now, arithmetic operators involve plus, minus, multiply, divide. This division is float division, and we have another operator which is double slash, which is float division. Then we have double star, which is exponent operator. So let us see how we can use them. So if I'll write 2 plus 3, I can do it on variables, I can do it on literals. If I'll execute this code, it will display 5. If I'll write 2 minus 3, when I'll execute this code, it will display -1. So numbers can be positive or negative. If I'll write 2 multiply 3, if I'll execute this code, this will display 6. If I'll write 2 slash 3, I'll run this code, it will display 0.666 up to 15 places of decimal. The precision for decimal number or float number is up to 15 places. So this is float division, means the answer will be in floating point. If I'll write 2 double slash 3, now see the difference. If I'll execute the code, it says 0. It will truncate the value after decimal. Now again we'll do something like this. If I'll write 23 divided by 2, when I'll run this, it will say 11.5. And if I'll write 23 double slash 2, I'll execute this code, it says 11. So this is an operator which is called floor division, which eliminates, which truncates the decimal point value after a given or in the answer. Now, if I'll write 2 double star 3, if I'll execute this code, it will say 8, which means 2 raised to the power 3. So this exponent operator is used to raise a given power to a given number. If I'll write 4 double star 0.5, it will give the under root of 2. So this is how we can use these arithmetic operators in our code. Now we can use relational operators also. The next type of operators we have in Python, they are called relational operator. Now relational operators define relationship between two operands, and these operators comprises of less than, greater than, less than equal to, greater than equal to, equality operator, and not equal to. Now how we can use them? For example, let's say if I'll write a equals to 10, b equals to 5. Now whenever we are using relational operators, they will display the value, or they will return the value in true or false, which is boolean. So if I'll write a less than b, if I'll execute this code, it will say false because a is greater than b. If I'll write a less than equal to b, then also it will display false because it is neither less than nor equal to b. If I'll write a greater than b, it will display true. If I'll write a greater than equals to b, it will again display true. If I'll write a not equals to b, I'll execute this code, it will say true. If I'll write a equals to b, I'll execute the code, it will say false. So this is how relational operators work. They actually tells us the relationship between the two operands. Now what are operands? An operand can be a literal, an operand can be a variable, an operand can be an expression. Based on the number of expressions or based on the number of operands, an operator can be unary, binary. For example, in all these cases, the operator which we had used, they are all binary operators because plus requires two operands both in both the sides, in left as well as right side. Now here if I am using -1, this minus is a unary operand which requires only one operand. So this is how we will be working with operators. In the next video, we will be discussing about logical operators and bitwise operators in Python. Thank you.